Hello, I'm Matt Helmers with Iowa State University Extension and Outreach. I'm here with Chris Hay from the Iowa Soybean Association. I'll let Chris introduce himself and the entity he's with at ISA.
Sure, so I'm a senior research scientist in our Research Center for Farming Innovation at Iowa Soybean.
Okay, Chris, we're out here in Humboldt County at a bioreactor site where we've replaced a bioreactor. Maybe tell us about the history of this bioreactor and a little bit about why we needed to replace it here in the spring of 2021.
Sure, so it's a bioreactor that we put in 2012, so it's a little over 8 years old now, almost 9 years old, and it's one that we've monitored as part of our water monitoring program for basically that entire time. And started to see some problems with the bioreactor. Actually, it's been several years now that we've noticed that it just didn't seem to be functioning properly. So, when we look at the nitrate concentrations, we'd still see pretty good performance. But when we look at the flow, it just seemed like it was always bypassing, and it didn't seem like the flow in here was matching what we were seeing in the flow out of the outlet structure. So. One of our staff members came out and actually tried to do some tests where he'd put more boards down in the inlet control structure and try and force more water in the bioreactor, and it just didn't seem like the bioreactor was taking it. It was just all bypassing. In fact, the water was almost coming up and shooting out of the inlet structure. So again, a pretty good indication that we just weren't getting the flow through the bioreactor that we needed. And so I think that's one of the things that points out about bioreactor management is we need to pay attention to both the flow and the nitrate concentration, because if we just looked at the nitrate concentration, it seemed like it was working, but it seems like that was just incidental drainage and we weren't getting actually flow from the inlet going into the bioreactor itself.
That'd be maybe one of the advantages, to be able to directly see that. In this case, right next to the drainage ditch, you could see where that outlet pipe was coming out, and so you could see that there was hardly any flow coming out of there. So you really could see that there was flow bypassing, but nothing coming out the other end.
Exactly. Yeah. We just, there'd be times where there'd be quite a bit of flow here, but just a trickle out in the outlet.
All right, Chris. So you saw that the flow was kind of all bypassing. Very little outflow. And I think then you came out to try to estimate some of the thickness of the wood chips that might still be in the bottom of the bioreactor.
Yeah, so I guess some different questions that we had as we were trying to figure out what was going on here was, we knew that we had a surface intake up there, and so that was one big question. Did we have a bunch of sediment that came down here and either plugged up the distribution line or, plugged up the wood chips there really close to the inlet? Or was it something more systemic across the entire bioreactor? So we came out here with a soil probe and an auger and dug some holes to try and see if we could see what was going on. So I guess we had good wood chips kind of in the middle, but a bunch of soil here at the beginning. That was kind of an indication that maybe it was more sediment coming down. If we weren't finding good wood chips in the middle, that was an indication of something else. And so, as we took several cores, we just struggled to find wood chips. So, there'd be 4 feet or so of dirt before we would get down to actually finding wood chips, and then we just weren't finding very much before we got down to the bottom of the bioreactor. So, again, there may have been some sediment that came down that was an issue, but it seemed like it was really across the entire bioreactor that we just weren't finding enough wood chips. And so I think it seemed like we were starting to lean towards that those wood chips had just gotten crushed or really compacted, and that was really what was slowing down the flow.
So as we think about a lot of the bioreactors, we typically might have a foot or so of soil on this, but you said this one had quite a bit more than that, and certainly.
Right, yeah, and we always trying to stay at a foot soil cap or maybe 2 feet if we really need to go to that depth, but we really don't want to get more than that just because of the weight of that soil. That overburden can really compact those chips, and so we were seeing quite a bit more than that. So it seems like from some of the pictures, it looked like they had a pretty good batch of wood chips, but it still seemed like there was quite a bit of distance there between the top of the trench and the wood chips. And so I think as that soil got put on, and maybe with the crown on top of that, and I don't know if there was some soil that washed in too, but we just had way too much overburden on that, and I think that was a big part of the problem.
Okay. So here in April of 2021, came out to this site and excavated the bioreactor out, took out the old wood chips. put in a blind inlet on that surface intake to try to reduce some of the sediment that might be coming down. I guess maybe comment on what you saw when contractors started excavating the old pit, the conditions of the wood chips, and did it confirm what you saw or what you thought from when augering those holes?
Yeah, it really did kind of confirm what we saw when we took the auger holes. In a lot of places there was 4, maybe even 5 feet in some places of soil over those wood chips, and again a really thin layer of wood chips. Down near the bottom end we saw some aerobic mold growth in there too. So again, another indication that we weren't really getting water flow through there. Those chips had really dried out down there. So yeah, I think kind of confirmed what we knew. The other thing was we didn't find a plastic liner, so it didn't look like this one was originally lined. And so that may have had some impact too. It was a pretty good clay base, but not as much clay coming up the sides, and so that may have had some impact as well.
And this one, after they excavated out the old wood chips, put that plastic liner in there, and then tell me a little bit about at the inlet and outlet of the bioreactor, because you did some different things there with putting some rock around the inlet. Kind of the inlet pipe and the outlet pipe.
Sure. So yeah, kind of took a belt and suspenders approach to trying to manage the sediment issues. Again, still not quite sure how much impact that inlet is having, but we knew we'd had some issues overall, and so we wanted to make sure we were giving ourselves the best, setting ourselves up for success and trying to manage sediment if it continues to be an issue. So, borrowed some ideas from ISG, their consulting engineering group. So, thank Bethany Brittenham and some of her colleagues for giving us some ideas on what they've done, some kind of unique things that they've done with bioreactor design to try and minimize sediment issues. And so, one of those was putting some aggregate or some gravel around both the inlet and outlet distribution pipes. And so again, as sediment's coming through there, we got a place to trap that before it gets in and plugs up the wood chips. The other one is we put a clean out on the inlet pipe. And so as that distribution line comes out into the bioreactor, we connected a couple of 45-degree bends in that pipe and then brought it all the way up to the surface. So we've got a piece of a 12-inch dual wall that comes all the way to the surface. And so if we see some sediment come in from that inlet, we need to clean that out. Now we've got easy access that we can run in and jet out that distribution line, which would have been a huge challenge before. You would have had to excavate that up to be able to clean it out.
Yep. And this one, when came in and redid it, has that more like the foot of soil cover over the top. So
right.
Made sure that.
Yep. So yeah, I think we're about a foot, and then with a little bit of crowning, maybe 1.5 feet in some places, but much closer to where we want to be as opposed to that really large overburden that we had previously.
So when this bioreactor was put in, it was pretty early in kind of bioreactor installation, and so at that time, kind of using the best available information, but it seems like it kind of illustrates the importance of some level of kind of evaluation or monitoring of these systems to see how they're working, and then kind of adapting how we manage them or how we put them in to make sure that they're kind of doing their job as we move forward and kind of understanding that. I guess any comments on that?
Sure. So yeah, I think this was one of the earlier bioreactors that would have gone in Iowa, and we've certainly learned a lot over time. And so, some things that were done with this one we wouldn't do now. In fact, the standard right now, the NRCS Conservation Practice Standard, wouldn't allow this bioreactor because of that surface inlet. And so, I think there's some work to try and look at if we can't use a bioreactor with a protected inlet, and so that's still one thing we're working through. And actually, hopefully that's one thing that this site will do, is give us an example of one with a protected inlet that we can see how that's working. But certainly, we didn't realize that the overburden was going to be as much of a challenge early on as it is, and so that's a lesson learned. I think there's still some questions about sedimentation in these bioreactors, even when we don't have surface inlets. And so, I think that's, again, some of the things that ISG's been kind of unique with, and looking at ways to try and give us some options to deal with sediment if sediment does become an issue. So again, we continue to learn. Again, this one's getting close to 10 years old before we redid it, and another one that we just redid was about that same age. And so, I think early on we talked about, well, maybe we can get 20 years of life out of these, but I think it's becoming more and more clear that we're probably looking at something closer to 10 years. But yeah, bioreactors are not a set it and forget it practice, and so we're going to have to come back occasionally and check on these things and make sure that they're working in the way that they were intended to.
So let's talk a little bit about the drain line coming into this bioreactor. Out there, you talked about that there was a surface intake and some concern about sediment. So as part of this project here, put in a blind inlet or gravel inlet, French drain, alternative intake, lots of different names, but essentially kind of a trench filled with rock. So instead of our wood chips, like we have our bioreactor, in this case we have aggregate material to try to let that water go through. That is 25 foot by 25 foot, 3 foot deep, with 2 foot of kind of coarse aggregate, and then a foot of fine aggregate, and then at the bottom of that are drain pipes to take that water away, and designed for a drainage area of 10 acres, if I'm not
That's correct,
mistaken.
10 acres.
10 acres. And then we wanted to look at a drawdown so that we would minimally impact the producer here. And so design standard calls for a 2-year, 24-hour storm event. And when we made that 25 foot by 25 foot, we got about 1.5 days for that to draw that down. So
Correct.
hopefully we'll see kind of minimal impact to the operations there. I don't know, any observations when we were putting that blind inlet in?
Yep. So this really was an intake that came, straight up to the surface. There was a little beehive grade on there, but not really much more protection than that. And when we excavated that out, there was quite a bit of sediment that was right there in that pipe, right there at the inlet. And so again, we knew we were getting some sediment that was coming down there at least. And so I think a lot of advantages with that blind inlet. That one, it is a chance to try and filter some of that sediment out before it gets to the intake. We've got the phosphorus benefit that's been seen in studies. So I think again we got some protection for phosphorus, we got some protection from sediment. The other nice thing compared to that open intake then is we can drive over this. We don't have to worry about hitting that intake and causing damage that way.
Yeah, and one of the things is that, because we kind of got a few questions when we were putting it in, it's just that fine aggregate all the way up to the surface. And so there is going to be that probably 25 foot by 25 foot that is unlikely to grow much of a crop, but that's probably made up for in the time that it would take to farm.
Eliminating some of that hassle factor.
Yeah. And so just to reiterate that the blind inlet is one of the practices that's been added to the Iowa Nutrient Reduction Strategy practice list since it was initially released in 2013, because some of the phosphorus benefits that we would get from this. And so I think probably one of the larger blind inlets that I've seen go in Iowa, and so it was nice to got some folks from NRCS that came out to see that go in. So kind of an opportunity to see something new, and a reason again why we from the Iowa Nutrient Research Center are interested to be involved, to see if we can see if that really helps us with the bioreactor. It may open up some opportunities for bioreactor installation where we might not otherwise want to put it if there's quite a bit of sediment coming down the line.
Exactly. Yeah. That if we're limited to sites that don't have surface intakes, that's going to knock out a lot of potential sites. And so if we can show that these alternative inlets or protected inlets can allow us to do a bioreactor, then that opens up a lot more sites to be able to do this practice. So I think that's hopefully a positive that comes out of this.
Yeah. In addition to, the blind inlet may provide us some benefits too. So hopefully this virtual field day might highlight how they're not too intrusive. Could be something else to consider on your farm as well, especially in these areas of north central Iowa where we see a lot of surface intakes.
And it's It's a practice we really haven't seen much of in Iowa. You know, thinking back to my time in South Dakota, you know, they were starting to become pretty popular in southwest Minnesota, and you know, the drainage in South Dakota was pretty new, and so you know, it wasn't this old established drainage, and so you know, I think there was a lot of interest in avoiding putting in those surface intakes, and so a lot of interest in these alternative intakes, and so you know, it's good to see that moving to Iowa now too.
Yep.